So, hi guys, today's video we're going to tackle the summary of chapter 9. Here I present to you the PowerPoint of the chapter 9, which is the transport layer. So, let's start. So, the first one is the role of the transport layer. So, the role of the transport layer is responsible for establishing a temporary communication session between two applications and delivering data between them. So an application generates data that it's sent from application on a source host to an application on a destination host. So this is without regard to the destination host type and the type of media over which the data must travel. So the path taken by the data, the congestion on a link, or the size of the network or the size of the network. So the transport layer network is the link between the application layer and the lower layers that are responsible for network transmission. So the next one will be the transport layer reliability. So the transport layer is also responsible for managing reliability requirements of a conversation. So different applications have different transport reliability requirements. So IP is concerned only with the structures, addressing, and routing of packets. So IP does not specify how the delivery or transportation of the packets takes place. Then transport protocols specify how to transfer messages between hosts. TCP or IP or Transmission Control Protocol or Internet Protocol provides two transport layer protocols. So the TCP or Transmission Control Protocol and the user datagram protocol or UDP is the IP uses this transport protocol to enable hosts to communicate and transfer data. So first one is the TCP. So TCP or Transport Control Protocol or Transmission Control Protocol rather is a transport is analogous to sending packages that are tracked from source to destination. So if a shipping order is broken up in several packages, a customer can check online to see the order of the delivery. With the TCP, um, we have three basic operations of reliability. So numbering and tracking data segments transmitted as specific host from a specific data. Application could reduce the usefulness of the application and can be um, detrimental in such as UDP is a better transport protocol. So the next one will be the UDP. So the UDP provides the basic functions for delivering data segments between the appropriate applications with very little overhead and data checking. So UDP is known as a best effort delivery protocol. In the context of networking, best effort delivery is referred to as unreliable because there is no acknowledgement that the data is received at the destination. So with UDP, there are no transport layer processes that inform the sender of a successful delivery. So UDP features. So user datagram protocol or UDP is considered the best effort So again, the UDP features is the user datagram protocol. UDP is considered a best effort transport protocol. UDP is a lightweight transport protocol that offers the same data segmentation and reassembly as TCP or Transmission Control Protocol. But without TCP, reliability and flow control, UDP is such a simple protocol that is usually described in terms of what is not compared to TCP. So the next one is the port numbers. So the source port number is associated with the originating application of the local host. The destination port number is associated with the destination application on the remote host. Then the second one is the source port, which is the source port. The source port number is dynamically generated by the sending device to identify a conversation between two devices. So another one of port numbers is the destination port, which is the client places a destination port number in the segment to tell the destination server what service is being requested. So the next one is the netstat command, which is the netstat command will attempt to resolve IP addresses to domain names or DNS and port numbers to a well-known application. So the negative N option can be usefully to display IP address and port numbers in their numerical form. So UDP datagram reassembly. So like segments with TCP, when UDP datagrams are sent to a destination, they often take different paths and arrive in wrong order. So UDP does not take track sequence numbers the way TCP does. So UDP has no way to reorder the datagrams in their transmission order. So therefore, UDP simply reassemble the data in order that is what it was received and forwarded it. So let's go to the summary of the NetAcad, which is the transport layer. So here's the summary in this topic. So the transport layer provides transport related services by dividing data received from an application into segments, adding a header to identify and manage each segment, using the header information to reassemble the segments back into application data, passing the assembly data to correct application, then UDP and TCP are a common transport layer protocol. So UDP user datagram protocol or datagrams, and TCP segments have had headers added in front of the data that include a source port and destination port number, which is I tackled a while ago. So these port numbers are enable data to be directed to the correct application running on the destination computer. So TCP does not pass any data to the network until it knows that the destination is ready to receive it. So TCP then manages the flow of the data and resends any data segments that are not acknowledged as being received at the destination. So TCP uses mechanism of handshaking, timers, acknowledgement messages, and dynamic windowing to achieve reliability. So the reliability process, however, imposes overhead on the network in terms of much larger segments, headers, and more network traffic between the source and destination. So if the application data needs to be delivered across the network quickly, or if network bandwidth cannot support the overhead of control message being exchanged between the source and the destination systems, UDP would be the developer preferred transport layer protocol. So UDP provides none of the TCP reliability features. However, this does not necessarily mean that the communication itself is unreliable. There may be mechanism in the application layer protocols and services that process loss or delay datagrams. So if the application has these requirements, the application developer decides the transport layer protocol that best meets the requirements for the application. So it is important to remember that the other layer all play a part in data network communication and influence its performance. So that's the summary of the chapter 9, which is the transport layer. So guys, hope you learned something from this video, and thank you for watching.